So let's apply the concept of item-based collaborative filtering to start with movie similarities, figure out what movies are similar to other movies. In particular, we'll try to figure out what movies are similar to Star Wars based on user rating data, and we'll see what we get out of it. Let's dive in. Okay, so let's go ahead and actually compute the first half of item-based collaborative filtering, which is finding similarities between items. In this case, we're going to be looking at similarities between movies based on user behavior. And we're going to be using some real movie rating data from the GroupLens project, if you go to grouplens.org, that actually makes publicly available to researchers like us real movie ratings data by real people who are using the movielens.org website to rate movies and get recommendations back for new movies that they want to watch. So we have included the data files that you need from the GroupLens dataset with the course materials. And the first thing we need to do is import those into a pandas data frame. And we're really going to see the full power of pandas in this example. It's pretty cool stuff. So the first thing we're going to do is import the u.data file that's part of the MovieLens dataset. And that is a tab delimited file that contains every rating in the dataset. So the way this works is even though we're calling read CSV on pandas, we can specify a different separator than a comma. In this case, it's a tab. So we're basically saying take the first three columns in the u.data file and import it into a new data frame with three columns: the user ID, the movie ID, and the rating. So what we end up with here is a data frame that has a row for every user ID, which identifies some person. And then for every movie they rated, we have the movie ID, which is just a numerical shorthand for a given movie. So Star Wars might be movie 53 or something. And their rating, 1 to 5 stars. So we have here a database, a data frame of every user and every movie they rated. Okay. Now we want to be able to work with movie titles so we can actually interpret these results more intuitively. So we're going to use their human readable names instead. If you're using a truly massive data set, you'd save that to the end because you do want to be working with numbers that are more compact for as long as possible. But for the purpose of example and teaching, we'll keep the titles around so you can see what's going on. So there's a separate data file with the MovieLens dataset called u.item, and it is pipe delimited. And the first two columns that we import will be the movie ID and the title of that movie. So now we have two data frames. rcalls has all of the user ratings, and mcalls has all of the titles for every movie ID. And we can use this magical merge function in pandas to mush it all together. And what we end up with is something like this. That was pretty quick. So we end up with a new data frame that contains the user ID and rating for each movie that a user rated. And we have both the movie ID and the title that we can read and see what it really is. So the way to read this is user ID number 308 rated Toy Story 4 stars. User ID 287 rated Toy Story 5 stars, and so on and so forth. And if we were to keep looking at more and more of this data frame, we'd see different ratings for different movies as we go through it. Now the real magic of pandas comes in. So what we really want is to look at relationships between movies based on all the users that watched each pair of movies. So we need at the end a matrix of every movie and every user and all the ratings that every user gave to every movie. And the pivot table command in pandas can do that for us. It can basically construct a new table from a given data frame pretty much any way that you want it. So what we're saying here, take our ratings data frame up here, and I want to create a new data frame called movie ratings, and I want the index of it to be the user IDs. So we'll have a row for every user ID, and I'm going to have every column be the movie titles. So I'm going to have a column for every title that I encounter in that data frame. And each cell will contain the rating value if it exists. So let's go ahead and do that. And we end up with a new data frame that looks like this. Kind of amazing how that just put it all together for us. Now these NaN values, that stands for not a number, and it's just how pandas indicates a missing value. So the way to interpret this is user ID 1, for example, did not watch the movie 1-900, but user ID 1 did watch 101 Dalmatians and rated it 2 stars. User ID 1 also watched 12 Angry Men and rated it 5 stars, but did not watch the movie 2 Days in the Valley, for example. Okay? So what we end up with here is a sparse matrix, basically, that contains every user and every movie, and at every intersection where a user rated a movie, there's a rating value. Okay? So you can see now we can very easily extract vectors of every movie that our user watched, and we can also extract vectors of every user that rated a given movie, which is what we want. So that's useful for both user-based and item-based collaborative filtering, right? If I wanted to find relationships between users, I could look at correlations between these user rows. But if I want to find correlations between movies for item-based collaborative filtering, I can look at correlations between columns based on the user behavior. Okay, so this is where the real flipping things on its head for user versus item-based similarities comes into play. Now we're going with item-based collaborative filtering, so we want to extract columns. So let's do that next. Let's go ahead and extract all the users who rated Star Wars. And we can see most people have, in fact, watched and rated Star Wars, and everyone liked it. So at least in this little sample that we took from the head of the data frame. So we end up with a resulting set here of user IDs and their ratings for Star Wars. And user ID 3 did not rate Star Wars, for example, so we have a not a number value indicating a missing value there, but that's okay. We want to make sure that we preserve those missing values so we can directly compare columns from different movies. So how do we do that? Well, Pandas keeps making it easy for us, and it has a core with function here that we can use. And that will actually go ahead and correlate a given column with every other column in the data frame and compute the correlation scores and give that back to us. So what we're going to do here is use core with on the entire movie ratings data frame. That's that entire matrix of user and movie ratings. Correlate it with just the Star Wars ratings column. We are going to then drop all of the missing results with drop NA. So that just leaves us with items that actually had a correlation, where there was more than one person that viewed it. And we will create a new data frame based on the results and look at the top 10 results. So again, just to recap, we're going to build the correlation score between Star Wars and every other movie, drop all of the NA not a number values so that we only have movie similarities that actually exist where more than one person rated it. And we're going to construct a new data frame from the results and look at the top 10 results. And here we are. So we ended up with this result of correlation scores between each individual movie for Star Wars. And we can see, for example, a surprisingly high correlation score with the movie Till There Was You, a negative correlation actually with the movie 1-900, and a very weak correlation with 101 Dalmatians. So now all we should have to do is sort this by similarity score, and we should have the top movie similarities for Star Wars, right? Let's go ahead and do that. Just call order on the resulting data frame. Again, Pandas makes it really easy, and we can say ascending equals false to actually get it sorted in reverse order by correlation score. So let's do that. Okay, so Star Wars came out pretty close to top because Star Wars is similar to itself, but what's all this other stuff? What the heck? Full Speed, Man of the Year, The Outlaw? These are all, fairly obscure movies that most of them I've never even heard of, and yet they have perfect correlations with Star Wars. That's kind of weird. So obviously we're doing something wrong here. What could it be? Well, let's talk about that in our next lecture. Turns out there's a perfectly reasonable explanation, and this is a good lesson in why you always need to examine your results when you're done with data, with any sort of data science task. Question the results, because often there's something you missed. There might be something you need to clean in your data. There might be something you did wrong. But you should also always look skeptically at your results. Don't just take them on faith, okay? If you do so, you're going to get in trouble, because if I were to actually present these as recommendations to people who like Star Wars, I would get fired. Don't get fired. Pay attention to your results. So let's dive into what went wrong in our next lecture. So that's our initial crack at item-based collaborative filtering and finding movie similarities based on user behavior, and the initial results really aren't that great. But it turns out there's a perfectly rational explanation for why and a perfectly simple way to account for it. So let's dive into what went wrong and fix it.